Hi, and welcome to day 3, where we're going to talk about similar triangle statements and the shortcuts. So, for the first part, this first video, we're just going to talk a little bit about the differences between congruent and similar shapes, and then we're going to talk about similar statements. So, when we talked about congruent shapes or congruent triangles, remember that our angles were congruent and our sides were congruent, and obviously our symbol was the congruency symbol. But the angles and sides had to be identical. Now, with similar shapes, the angles are still going to be equal. I'll put that over here, equal. Sorry about that. But now our sides are going to no longer be congruent or equal the way they were when they were congruent shapes. The sides are going to be proportional. And remember, we've been talking about this whole concept of scale factors and similarity ratios, and one shape being big and one shape being small. That's how we'll find similar figures, is through the proportional sides. And remember, the shape or symbol for similar is that squiggly line. All right, so just a little chart here. I'm going to show you the congruence and similarity shortcuts. What we had to prove for congruence, we had to prove that corresponding angles were congruent and that corresponding sides are congruent. So if you look at the chart, the sides had to be congruent, the angles had to be congruent. But now what we're going to have to do for similarity is we're going to need to prove that the angles are congruent. That still stays true, but now we have to prove that the sides are proportional. Now, if you recall, during our unit on congruent triangles, we had 5 shortcuts. We had side, 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 angle, side, angle, side, angle, 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 side, and HL. Well, for similar triangles, we only have 3 shortcuts: angle, angle, which we did not have, side, angle, side, and side, 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 which we did have under triangle congruence. So you'll see some things that are the same and things that are different. Okay, and I think that this part we're good with because we've already covered congruent triangles. So let's skip over to page 12, and we're going to talk about a similarity statement. So remember that with a similarity statement, just like a congruent statement, you have corresponding sides and corresponding angles. But the difference here is that the sides are not going to be written as congruent when the triangles are similar. They're going to be written as proportions or ratios. However, our angles, F goes with J. That means angle F and angle J are still congruent. Angle G, angle K are still congruent. Angle H and angle L are still congruent. But if we're looking at our sides, FG and JK are now forming a ratio. GH and KL are now forming a ratio, and FH and JL are now forming a ratio. So let's practice doing that here. We're going to take this diagram. I'm going to use my pointer. We're going to use these 2 shapes, which are not triangles, by the way. It's some sort of quadrilateral, 4-sided polygon. And we're going to list all the pairs of congruent angles, and we're going to write a proportion just like this that relates the corresponding sides. And it's not as hard as it sounds. So let me grab a pen. Let's do the angles first because the angles are always super simple. So if I have angle N is congruent to angle U. Angle P and angle V. Angle Q and angle S. And we have a fourth one here because this is a four-sided shape. Angle R and angle T. So there's our angles. That's list all pairs of congruent angles. Done that. Now we have to write the proportion that looks like this that's going to relate the corresponding sides. So all we have to do is find our pairs and make them a fraction or a ratio. So NP corresponds to UV. See how we wrote it like a ratio or a fraction? Now we're going to go get another pair of sides. PQ and VS. Now we're going to get a third pair of sides, QR and ST. But we are going to have a fourth pair of sides here because these are four-sided polygons. So where that's going to come from is NR. Everybody see NR and UT. Now, one thing to notice when I set up my proportions, I put the left hand side, this is my left, in the numerator, and this is the right hand one. I put that in the denominator. And why did I do that? I just chose to. I could have done it the reverse. I could have put the right hand polygon in the numerator and the left-handed polygon in the denominator. But for me, like I said in the previous video, I do it the same way every time. And I just don't like to deviate. It keeps it simple. If I always go left to right, top to bottom, it sticks for me. So we've written our proportion and we are done. So what's going to happen here is you're going to practice doing that in problems 3 and 4. And in problems 1 and 2, you're just going to, I guess you're doing the same thing. Yes, 1, 2, 3, and 4. And then we'll come back in the second video and we'll be on page 13. And I'll show you the long method for figuring out if two triangles are proportional and similar or not. Thank you for watching.